Good day, ladies and gentlemen. You're all very welcome to today's presentation of the CNPS. And I must apologize for the procrastination. There have been some technical problems. This is actually one of the weeks where Roger Anderton is hosting the session, as you will know from the announcements. But unfortunately, he's having connection problems. He's actually trying to connect at the moment. And if you like, it's a bit fortuitous that I'm here. Both Franklin Hu and I have admin capabilities of running the meeting, say in the host's absence. Now, I personally, Ian Cowan, run it every second week, but this is not one of my weeks. And normally I'd be away actually today, but it's just so bad. The weather's bad that I haven't been invited out on a tour. So I'm at home. So just discussing it with Nick Percival and James Keane, who are here. We thought as a stopgap, we have two things. Nick has a video on the twin paradox. Cornelis has just come in as well. And I actually was doing a little preparatory work just 10 minutes before the meeting. I have in Appendix 2 of Alf Kelly's book, Challenging Modern Physics, 54 proposed explanations of the twin paradox. And between those two things, it might be interesting to go through those, and then maybe we could get back to discussion. I'm not sure if Roger has succeeded in getting in now. So, well, okay. First of all, let me add Roger to the stage, at least momentarily. If you speak, can we hear you, Roger? No. It's there's no sound. There's like a bit of distorted noise coming through. So, Nick, have you located that video yet?
Yes, I have located one of my videos. It's probably very basic. Let's see, where are you? Here we go. Can I email the URL to you?
Oh, you could certainly email the URL, yeah. Or you could put it in the chat. You see the private chat. If you click private chat, that's only between the few of us.
Okay. I just sent it.
Right. Now, I have to, we just might have a moment to do this. It can be done. I have to share my screen and get the video up and so on. So first
I apologize that it's going to be a red print on black. It was one of my earlier videos. So hopefully you can read it.
Okay, I think that's the least of our problem. Least of our problems. Okay. I've just wait a minute. I want to pause this video. I've paused the video. I now have to share my screen, so just bear with me. This is all seat of the pants.
Yeah, it'll come up.
Yeah. So let me see now. I'll present share screen. No, I hope this works. We were having trouble last week doing this. So you just tell me if you can see it. Can you see that now?
Yes, I can.
Can you see it?
Yeah.
Welcome to.
You can, and you can hear us as well. Okay. Well, I'm going to proceed now. And viewers, press the little icon in the bottom right-hand corner to maximize your screens.
This seventh talk in this series.
Yeah, you can get rid of our pictures, right?
Specific.
Sorry, is somebody talking there, Nick?
This is Nick.
I thought I could hear you.
You can get rid of you and my picture on the left, right? That'll make it bigger. Maybe not. Maybe not.
I don't have it up at present because I've maximized my
screen.
Maybe I can minimize it and then No, I don't have the pictures there. Okay, it's just I thought I heard you speaking, and I thought if you we might be getting through your mic, or even my mic, I dare say, a feedback. So I want to get rid of that. Yeah, I'm going to do what you've suggested. Actually, I'm going to bring the two of us down.
I just see me on the screen.
It's just stopped allowing me to start the video again for some odd reason. Odd, very odd. I think I may have to start from scratch again. So just
Specifically about time dilation, and we'll get into the topic of the famous twin paradox. For two inertial clocks, A and B, whatever special relativity time dilation effect occurs, for A versus B, the same special relativity time dilation effect have to occur for B versus A. As you see, I'm abbreviating time dilation with TD. So time dilation has to be symmetric between the two inertial clocks that are involved. Why is that? Well, both the relativity principle and special relativity assert that all inertial frames are indistinguishable. But if we had different effects for time dilation between A and B versus B and A, then they would be distinguishable. In fact, it would imply a hierarchy in terms of relative clock rates. In addition, special relativity time dilation is a function of relative velocity, which is the same for A to B as for B to A. If you have clocks A and B, and they're approaching each other with relative velocity 5 miles an hour, then the relative velocity for A approaching B is 5 miles an hour, and the relative velocity for B approaching A is 5 miles an hour. And conversely, if they're separating by 5 miles an hour, it's going to be the same of A to B and B to A. So there are some consequences to that. And that's a key concept. If you forget it, you need to come back, look at the slide again, because it's going to underlie all that we talk about for a number of different topics. There are two interpretations of special relativity time dilation that are used by relativists. In fact, most relativists use both of them together, not just that we have two different competing camps, camps supporting one interpretation and another supporting the second interpretation. Individuals use two contradictory interpretations. From what we talked about in the previous slide, one cannot interpret special relativity time dilation as claiming that clock A is accumulating proper time faster or slower than clock B. Proper time is just the amount of time that accumulates on a clock. Well, as Dingle put it, if you try to interpret special relativity times dilation as causing different proper time accumulation, one clock slower or faster than the other, then that requires that clock A works more slowly than clock B, and that clock B works more slowly than clock A, which it requires no superintelligence to see is impossible. That's a direct quote of Herbert Dingle, who was indeed a great physicist. Many other great physicists and critical thinkers agree with Dingle. And there I give a partial list, and earlier I gave a much, much longer list. So again, there are two interpretations of time dilation. We cannot have the invalid interpretation that special relativity time dilation describes physical clock slope or physical clock rate differences. But we can interpret time dilation as describing a just observed effect of A, measuring or observing the B clock to be slow, and B, measuring or observing the A clock to be slow. Unfortunately, relativists routinely use both interpretations, even though they're mutually exclusive and contradictory interpretations. And in addition, we've just clearly seen that one of those interpretations has to be invalid. Okay, what was the origin of that invalid interpretation that time dilation is talking about clock slowing as a function of relative velocity? Well, in the paper that Einstein had published in 1905, that was the seminal paper for defining special relativity. He had, after deriving special relativity time dilation, he made his twin paradox claim, which implied the invalid interpretation of time dilation. And when I'm talking about time dilation, I'm always talking about special relativity time dilation. That claim, namely that proper time accumulation rates change as a function of relative velocity. In the paper, right after he derives special relativity's time dilation equation, he says, from this, clearly referencing the time dilation equation, if two clocks are at rest in an inertial frame next to each other, and one clock makes a round trip, then it will return having accumulated less proper time than the clock that didn't move. Initially, that was called the clock paradox, and later the twin paradox.
This €49 heating gadget warms up your room in minutes. This space heater is being called the Tesla of heat.
Let's just take a look at a picture of that claim. Basically, Einstein was talking about clocks. But if you think of human beings as biological clocks, their aging is like a clock, then it could be interpreted as follows. We have two twins there in the upper left. One is the astronaut twin. He gets into his rocket ship. He blasts off. He goes to some star system many light years away, and he doesn't stop there. He just turns around after filming everything and comes back. And you can see in the lower panels that the stay-at-home twin has aged greatly. But the traveling twin, because he was traveling so fast that the time dilation effect would be very, very large. He's aged hardly at all, but the twin that stayed at home, he must have aged about 50 years. That was the claim. And I guess it's this picture about the twin paradox claim and all the excitement about astronauts that's stayed in everyone's mind. So they think of the special relativity time dilation effect as causing differential clock rates or differential aging. Even though Einstein himself abandoned that interpretation, in effect, in 1916, it still lives on today. Okay, what was the initial reaction to Einstein's claim? Well, from 1905 to around 1919, many physicists objected to the twin paradox claim. They, in effect, said, how can a symmetric effect, the time dilation effect, produce an asymmetric effect, a difference in the proper time, the amount of proper time that was accumulated? Well, that question has never been reconciled with special relativity time dilation. However, the empirical data shows that clock rates are indeed a function of velocity. But that effect cannot be caused by special relativity's time dilation, because that's an invalid interpretation, as we discussed. So it must be caused by some other effect, such as a preferred frame theory, like the Lorentz ether theory. I've mentioned Lorentz ether theory, but I'm not endorsing the entire Lorentz ether theory, all of the details about the ether and whatnot. I'm just really talking about how the Lorentz ether theory treats time, namely clock retardation, where you have clock slowing as a function of velocity with respect to a single inertial frame and really a single physical entity, which in the details of the Lorentz ether theory is the medium, the ether rest frame. But it could be some other single entity, such as the local gravitational field rest frame. But a single preferred frame rather than special relativity's velocity with respect to each and every single inertial frame. So that's the basic discussion for today, and we'll continue to build on that and give more details in the next few sessions. Thank you very much for joining us, and hope that you'll come back next time. Thanks again.
Okay, I'll stop. I'll stop sharing now. Stop screen. I think that's probably stopped everything now. Okay, I think Roger has had to give up because he's having trouble with both his computers, but he still seems to be there, so perhaps he may be able to participate later. There's been a lot of comments 43 comments since, and I don't know, probably just a lot of them are discussions among themselves. Okay, now, so if you think it's appropriate, I could maybe advert to these so-called explanations of the twin effect, which have been given in the literature. Now, unfortunately, I don't have any slides or anything like that because this is completely ad lib. But I have them here, and perhaps I could just go through them. It'll take a little while, but I'll not labor it too much. Yeah, Roger's microphone doesn't work, unfortunately, so he's going to have to type in anything in the chat when we get to the discussion, Roger. Okay, so in this book from by Alf Kelly on questioning Einstein's relativity theory, challenging modern physics, in Appendix 2, he talks about the twin paradox explanations. So these are the explanations that have been proffered in the literature. And he presents them in chronological order. So number one is Einstein's 1905 paper, which he says gave rise to the problem in the first place by not making a reciprocal statement on the time recorded on a stationary clock as viewed from the moving frame. Einstein did not refer to acceleration or deceleration, but depended on a large polygonal or orbital path coming back to the same spot. So just note that, because many of the explanations later for the asymmetry are based on the moving, the voyaging twins accelerating and decelerating to come back to the same spot. Now, the next one is Langevin in 1911. According to Kelly, he seems to be the first proponent of the paradox. He thought the difference was caused solely by acceleration, occasioned by the reversal of the traveling twin when changing direction to come back to Earth. And he says, and quote, "The most certain experimental facts of physics enable us to confirm that this is so." But Kelly adverts that by this he means that relativity theory just has to be correct. While he agrees that each of them will see the other age 200 times more slowly than usual, he asserts that it is only the traveling twin who ages more slowly. Okay. Langevin still comes to the strange conclusion that only one twin ages slower. Significantly, he gives no calculations. Okay. Then in 1912, a year later, von Lau said, "Relativity principles claim that all time scales are the same in all directions, but the Einstein experiment is presented as a warped world line which diverges into two different paths at world spot A and which is unified together again at world spot B." So I'm not reading every single explanation in detail because that could take about half an hour. I'm trying to crystallize the main aspects from them. So he says, von Lau, these two things prove the above objection to the theory of relativity. Otherwise, one would have to upset this fundamental law of the isotropy of space using the simple geometrical construction. So Kelly concludes that in this statement, von Lau did not agree with Einstein. Now, Pauli in 1921 is next. He said that Einstein's explanation of 1918 was correct and that it could be explained only through the 1916 general theory of relativity. So that's the first time that the general theory has been brought in. Okay, so that's it. Pauli mentions that this book of his was penned at the tender age of 21, which according to Kelly would not have any significance in the debate, which I'm sure is true. Now, a year later in 1922, Bourne, as quoted in Lovejoy, whom we'll talk about in a moment, he said of the paradox is, in truth, a marvelous one, but one which no quibbling can escape. We must simply adjust ourselves to it, as some centuries ago our ancestors adjusted themselves to the idea of men standing on their heads at the antipodes. From which Kelly concludes, perhaps we have to stand on our heads to understand the matter. Now, Lovejoy, who was quoted a moment ago, in 1931, said, in relation to the reciprocal relative motion of relativity about twins who never reverse or meet again, an idea such as proposed in this book. Yeah, I think here he's talking about maybe you might have the twins moving around a cylinder and meeting without having to reverse direction. So Lovejoy says, Paul will be alive while Peter is dead, and also Peter will be alive while Paul is dead. That is to say, Paul will be simultaneously both dead and alive, and Peter will simultaneously be both dead and alive. So Kelly says that Lovejoy's analysis demolishes the argument that the relative ages are an illusion. In Nick's video just observed, or only thought to happen by the parties concerned, because being 200 years old means that one is dead. So Lovejoy sends the twins in opposite directions along parallel tracks for the duration of the test. He does not have them meet again and suggests the use of a camera as suggested in this book. This is a clear expose of the nonsense involved. So a year later, 1932, Lynch says, this is Arthur Lynch, I was led to the point where I had to accept the conclusion that a clock would go fast or slow according as it moved relatively to imagined sources of coordinates. Now Lynch was one of the skeptics. He wrote a book, The Case Against Einstein, in 1932. Most of the people here we're quoting, I think, were sort of proponents of the SRT. So in 1934, Tolman states that whether we consider A or B to be the clock that moves, we obtain the same expression for the relative readings of the two clocks. He then proceeds to bring in the general theory of relativity and claims to have an explanation of the one-sided aging. This mirrors Einstein's 1918 attempt. Now, in 1937, Ives, who was not necessarily orthodox in this regard either, says, let B be moved to a distant point at the velocity v with respect to A and back to A. It will on its return be slow with respect to A. But if relative motion is only of significance, A is likewise moving at the velocity v with respect to B, and hence it will, when the clocks are together again, be slow with respect to B. So Kelly says, Ives believed that the paradox was inexplicable. In 1952, Muller, in his textbook, The Theory of Relativity, says, a clock which is moving with the velocity v relative to s will be slow compared with the clocks in s. When we keep in mind that the systems s and s prime are equivalent, it is obvious that a clock at rest in s similarly will lag behind the clock in s prime. Here, Muller clearly states that either clock runs slower than the other. He attributes the difference in ages to the general theory of relativity, but without saying how and why. In contradiction of his earlier statement, it does not rely on the general theory, but on the special relativity. We look at that in Lefford and Donoghue below. So Brewster in 1956, a medical doctor, says, it depends on whether you say the spaceship is moving away from the Earth or the Earth is moving away from the spaceship. No matter which twin brother you are, you will see the other as aging faster. When the two of you are back home, however, one will not be any older than the other. This contradicts Einstein. Now, Darwin in 1957 gives a mathematical derivation and does not calculate the change in time during the acceleration phase. he says that the direct effect of acceleration can be disregarded. So that's in contradistinction to what others are saying. And this directly contradicts Einstein's 1918 analysis. Darwin's analysis was later challenged by Dingle in 1960. Fry and Brigham in 1957 say that the general theory is needed to explain the matter. Builder in 1958 assumes that the motions of bodies and clocks through the ether do cause reductions in length and rate. But he is assuming that it is accelerations that make the difference when he states that the second clock is observationally distinguishable from the first by the fact that in its journey away and back to the first requires that it should be subject to accelerations. Kelly says this is a typical cop-out. No explanation is offered. So just saying it's acceleration, which results in asymmetry, but without giving any calculations or details. They say this has been experimentally proved, but no experiments have been done, obviously, to verify this. So they're really just thought experiments. Now, back in the same year, in 1958, Leffert and Donoghue, whom I mentioned a moment ago, point out that Muller in 1952 had not solved the paradox, but had introduced another equally inextricable problem. So we're continuing on, and we're in a muddle. Now, in 1959, Muller again agreed that Leffert and Donoghue had shown that it seems that the solution of the original clock paradox, as presented by the present author, introduced a new paradox as regards the clocks. So he then brings in things like the mass of a twin is supposed to change suddenly from plus to minus at the reversal of his journey. This must be an interesting experience, Kelly says. We have seen earlier that Muller's 1952 analysis, which is one of the few detailed mathematical expositions on the subject in a standard physics textbook, is nonsense. So again in 1959, Builder, it seems to be a lot of explanations in the 1950s, states where R is the fixed rate and M the moving clock. It has long been supposed that we are therefore forced to conclude that the restricted theory leads to the contrary prediction that the clock R would become retarded relative to the clock M moving in the experiment. By restricted theory, he means special relativity. He continues, what should have been obvious from the very first, that is, that the calculations were meaningless because the data were not all expressed in terms of the measures of the same reference frame. So Kelly concludes, the contrary to Einstein's 1918 explanation, Builder says that it will be assumed that any effects of acceleration and deceleration of M can be neglected. And this contradicts the earlier 1958 paper by the same author. Now, Romer in 1959, while setting out the problem, began with the method independently advocated in this book of having one of the twins already moving at constant speed at the beginning of the experiment. For simplicity, any possible questions about the effect of the initial acceleration are avoided by having B already moving with respect to A at the beginning of the problem. He requires 4 people, actually, all of the same age, to carry out his analysis. He proves fairly conclusively that A and B are both younger than each other at the end of the experiment. Since in the process of turning around, they do not remain in an inertial system and thus have no assurance that their clocks, if originally synchronized, will remain synchronized. But that, according to Kelly, is back to the let out. So come to 1916 now. Sherwin says that Dingle was a pure relativist and denied the possibility of predicting the time difference of the two clocks solely from the knowledge of their relative motion. Dingle was accused of believing that it is only relative motion between two physical objects which has meaning, and that the rest of the universe what the rest of the universe is doing does not make any difference. Kelly says we should certainly agree with Dingle that Dingle was right in this regard. Contrary to many so-called experts, Sherwin says that all of the phase differences accumulated during the constant velocity regions of the path. He could see that the acceleration phase could be made tiny and that this period could not be blamed for the one-sided forecast. So those are two quite contrary explanations. One, acceleration means everything. Two, acceleration is irrelevant. In 1963, now, Lowry calculated that the traveler's time is really slower than the stationary clock, and that the traveler will think the stationary clock reads less than that again. Yeah, so actually he says, so this actually doubles the effect calculated by any other author, because one thinks the other is slower, so you have to get twice the difference. However, Lowry does not then refer to the ironic reverse situation. Bondi in 1964 and 1967 says that the difference is caused by acceleration. He asks, how can all the time have got sunk in the relatively short period of acceleration? Vaguely mysterious. Fock in 1964 says, such a comparison will show that clock B is running slow compared to A, and the same equations appear to predict that A should be slow compared to B. Of course. Levi in 1967 says, however, from the astronaut's point of view, the Earth twin will have aged more slowly during the trip, and yet, surprisingly, he finds himself older rather than younger. Indeed, this is surprising. To get out of the impasse, Levi then says, during the acceleration at the turning point, he will observe himself to age significantly. That will be an interesting experience, Kelly says. Watch out for this every time you start and stop your automobile. French, I'm trying to go through these reasonably quickly because it'll absorb too much time, so that we can have a reasonable discussion about them. But I'd like to cover them all. So unfortunately, I'm only about halfway through them. But I'm up to 1968. French, is one of the few who refer to Einstein's original 1905 paper. He refers to a raging controversy that ensued during the years 1957-1959, following preliminary skirmishes back to 1939. He says that SR explains the paradox because the switching of inertial frames by the traveling twins caused the whole difference. He also says that the paradox consists of a one-sidedness that appears to flout the basic tenets of relativity. However, he does not agree with the authors who depend on the general theory to explain the paradox. At the end, he finishes with a hope. One must hope that the matter is finally settled. In 1970, Marder says that the general theory adds little to the interpretation of the clock paradox. Kelly says how right he is. In 1971, Essen, whom Nick has referred to, he said that, looking at the reciprocity, you get clock B viewed in A as slower than clock A viewed in B as certain clock B. And he quotes in a long aspect. He says, finally, it is assumed to be valid for a closed curve, so that if a clock makes a final round trip from A, it will be slower on its return than a clock that has remained at A. Although the clock must be accelerated during the journey, no allowance is made for any effect of the acceleration, which indeed is not mentioned. So Kelly says that the statement, which he quotes in toto, is given because Essen was the inventor of the cesium clock and was the director of the time control department at the Greenwich Observatory. He was an expert in this field and he knew exactly what was involved. It seems that perhaps his career was terminated or prorogued because of his questioning the whole principles of relativity. Holstein and Swift in 1972 say that there is almost universal agreement on the results that would be obtained could the experiment be carried out, at least an admission that the experiment has not been carried out. He says, count this author, Dingle, and many others out. Holstein and Swift then say, there is something peculiar about the fact that free fall in a gravitational field can turn an inertial frame around. There sure is. Same year, 1972, Greenberger had a problem with the twin paradox. He says, if one accepts the postulates of relativity, then one must necessarily accept the twin paradox effect as an essential consequence. But one must recognize that by altering any of the basic assumptions of the theory, one is constructing a different theory, which Kelly says is close to an outright challenge to the theory of SR. Muller in 1972 again then says that although the paradox is resolved when one uses the equations of special relativity more carefully, it is surprising how few physicists are aware of the explanation and think that the explanation lies somewhere in the realm of general relativity. And then he quotes, he says, they agree about each other's age only when they are in the same Lorentz frame or separated by zero distance. To which Kelly says, all of this contradicts Einstein's own explanation. How about taking photographs every few years and comparing them when the twins eventually meet up? Come to 1973 now, Markley did not pontificate on the matter, but came to a moderate conclusion that the twin paradox turns out to be less paradoxical than it originally appeared. Only less paradoxical, Kelly says. The reader cannot but be impressed by the frustration of some of the investigators. Several authors imply that other physicists did not previously appreciate the simple explanation now being put forward with vivid clarity by themselves. So all these people are generally not in agreement, but they're giving, the absolute explanation according to themselves. Again, 1973, Durso and Nicholson say that the asymmetrical aging of the relativity twins in freefall can be predicted if they do sufficiently sensitive experiments to detect asymmetrical tidal forces which exist in their local reference frames. To which Kelly just appends two words: tidal baloney. Brahms and Stewart in 1973 use a concept of flat space-time, which is spatially closed on itself. More specifically, they say there are no obvious kinematic, dynamic, or geometric distinctions between the two, and yet one experimentally verifies that the moving clocks are slowed while the other does not. Now, again, by using the word experimentally, these physicists give the impression that an actual experiment was carried out. This is not so. The whole thing is merely a thought experiment. They conclude that the principle of special relativity, although locally valid, is not globally applicable. Mysterious. This is the opposite argument to that discussed earlier, where the Sagnac effect, which has claimed that time might be locally different, but that generally is not the same. I think that's a principle put in by people like Langevin, which Kelly had discussed earlier in the book. So come to 1976 now. Hall says, naive use of relativity can make it seem that each twin would expect the other to be younger. Of Dingle, Hall says that the perennial chief skeptic has still not given up his quixotic crusade, to which Kelly just says, name-calling is a sure sign that the caller has lost the debate. Essen again in 1978 says, students are told that the theory must be accepted, although they cannot expect to understand it. They are encouraged right at the beginning of their careers to forsake science for dogma. Right, Kelly says. 1979, Perrin says that the crux of the resolution involves calculating the time that passes on the Earth when the traveling twin changes inertial frames. All clear as mud, Kelly says. In 1979 still, Turner says, there proves to be no way to maintain that gravity and acceleration equally slow clocks down or equally slow the aging process. Gravity slows clocks, acceleration does not retard clocks. Hence, Einstein's resolution of the twin paradox is not a factual resolution at all. Come to 1981 now, Unruh says that he came up with another twist in the paradox while postulating that. By the way, all these references are available in Kelly's book, and if any of them, struck you and you want to know, just ask later. During the period of acceleration, the accelerated observer sees the other traveler recede and go backwards in time. Here's a new principle now. Roger's not able to come in. He's been trying. This motion completely reconciles the calculations both observers make regarding the reading of each other's clocks. Many authors use the acceleration-deceleration phases as a useful cop-out. By merely saying that these phases are not inertial, they seem happy. They do not attempt any further explanation. It seems as if it is sufficient to remark that it is not explained thus. Rindler in 1982 says that the eventual age difference between the twins can be seen to arise during the initial acceleration of the traveling twin away from the stationary observer. How much aging occurs then? If it is true that the period of aging, why not just accelerate away and then decelerate and come back immediately after, say, 1 month, rather than spending 60 years away? It is harder to justify the strange claims if the traveler is said to be away for a month and to have aged significantly over the short period. These are Kelly's remarks. Does the aging stop for a traveling twin for those years? For example, if all the aging occurs in the first year, what about the next 59 years? So come fast forward now to 1987. Dislodge and Philpott comment upon the misconception that one encounters in many of the standard treatments and also overlooked facets of the phenomenon. They say that acceleration phase has nothing to do with the solution and that the general theory is also relevant. Einstein in 1918 says the opposite, as quoted at length earlier in his paper on the specific topic. Sastry in 1987 says, everyone agrees that there is no symmetry in the twins' motion, and so no paradox, but then adds, perhaps the last word on the twin paradox has yet to be said. Indeed. Hawking in 1988 explains that it is a paradox only if one has the idea of absolute time at the back of one's mind. In the theory of relativity, there is no unique absolute time, but instead each individual has his own personal measure of time that depends on where he is and how he is moving. Kelly says, how comforting. 1989, Brown sent two rockets with a distance between them at launch. He remarks, in opposition to Einstein's 1918 effort, it is wrong to suppose that the reduced aging is a direct result of acceleration. The age difference of the twins is proportional to the length of the trip, while the period of acceleration is determined only by how long it takes to turn around and is independent of the length of the time of the trip, hence the final age difference between twins. So far, so good. Broun then tries to show that the twins who are sent off at the same rate of acceleration age differently, if you had that experiment done. Okay, which is interesting. Come back to 1990. So we're getting near the end. I'm going through all these very quickly, but I hope they'll give you an idea of how confused the whole system is. Dre in 1990, while postulating what he calls a cylindrical universe, which I talked about a moment ago, unlike an ordinary spatial relativity, there is no preferred time direction in a cylindrical universe. There are two effects here. The one described above is due solely to special relativity and is called the Sagnac effect. Now, of course, the Sagnac effect has nothing to do with special relativity. So that's basically what Kelly goes on to say. And the introduction of a cylindrical universe is suitably mysterious. Lau in 1990 states that, unfortunately, one might argue that B can do exactly the same calculation and come up to the conclusion that A's clock ought to show less elapsed time than his own, after all. The entire technology of using Lorentz transformation is suspect. With another example of the cylindrical model of the universe, Lau has an amusing explanation. Those are Kelly's words. Quoting Lau again, A keeps watching B as B travels away from him. Then he observes B's clock going slower than his own. What he will not expect is that, in fact, B has come up behind him and is back at x equals 0. What next? Ironically, if one of the above were to be believed, then the opposite should also apply. Therefore, if the traveler is supposed to be the one who really is found by both twins to age, to a lesser degree, then according to the basic tenet of relativity, that it is solely the relative velocity that is of importance. The reverse should also be true. We are now sufficiently confused, Kelly says. In 1991, Winkler, in a paper on the synchronization of standard clocks around the world, castigated other authors. The next step can easily lead to a fatal error made by many people, even experts, the error of the clock paradox. In referring to the reverse situation where the twin who is considered to be moving in the first computation is taken as the stationary one, Winkler comments, claims that relativity means that the relative situation is the same are false. The situation is clearly not symmetric. The clock that moves non-uniformly is always slow compared to one inertial clock. However, these are Kelly's words again. However, who says there is an inertial clock? What of the mutatis mutandis statement of Einstein, where he talks about this, all things being equal? We are listing here all the experts who make such fatal errors. Still in 1991, Dislodge and Philpott had a second article in which they say failure to think locally rather than globally are the true sources of the difficulty. And they say that Broun's puzzle is pedagogic. This is where he had the two rockets going off together. Young's physics in 1992, a textbook, states that because one of the twins is observing in an inertial frame, the other must have an acceleration with respect to this frame in order to turn around and come back, and that this difference causes the traveler to be really younger on return. The textbook says that careful analysis shows this to be true. Oddly, it does not give the supposed mysterious careful analysis, Kelly says. Is this the only instance in this university text where calculations are avoided? Kelly in 1995 and 1996 shows that the time does not change aboard a moving object. This dispels the paradox because neither twin ages differently from the other. I think this is probably mainly from his analysis of the Sagnac effect. That's just my own comment. So come on to 1996 now. Debs and Redhead say that direction reversing acceleration has nothing to do with the explanation of the paradox. It is interesting to see the opposing views on this point alone. This long article purports to provide a way to settle the often discussed issue. They say that there is an infinite class of possible accounts, none of which is privileged. So now we know the above selection of explanations is merely a sample from an infinite series of explanations that will go on forever, says Kelly. Again in 1996, Price and Gruber give an amazing conclusion in this paper, which says, we've given different answers to the question, where does the differential aging occur? One, it all occurs during the twins' rocket trip. Two, it occurs in the twins' early pre-rocket years. The lack of unique answer shows the lack of meaning of the question. Age difference in relativity has a well-defined meaning, but the origin of age difference cannot be assigned to any specific part of the explanation. So Kelly said this is one of the most outlandish of all. It proposes that some of the age difference that is subsequently caused by the high-speed travel actually happens before the travel starts. So maybe two of the most outlandish explanations that we've gone through here, one, that time moves backwards, and the other that some of the aging occurs prior to the start of the travel. Okay, we're coming to the end now. In 1988, Blau continues the nonsense, according to Kelly, as follows. If the space in which the twins live is a circle, then the sister can return to her brother without accelerating. Each twin sees the other moving uniformly and might claim the other's clock runs slowly. Of course, this cannot be so, which is the twin paradox on the cylinder. One says cylinder instead of circle because the topology of the two-dimensional space-time is cylindrical. Basically, he goes on, he says, twins at rest with respect to these privileged observers always age more than their siblings who travel around the cylinder and meet them. Kelly says, what a statement. Now, the year 2000 brought Cranor et al., where they used the example of two rotating rings that rotate in opposing directions. Each twin is on a ring. The twins pass each other as the rings counter-rotate. Cranor et al. Try to explain what each twin will see the other as aging slower, while the symmetry of the setup demands that they will agree on the time elapsed each time they meet. This is a difficult task. How do you reconcile the two? They propose that there is a discontinuity in synchronization in the position of one twin, like jumping time instead of jumping frames. So there's a bit of an outlandish thing. Time jumps when the two come together. Because, see, we know SRT must be correct. So we try any explanation under the sun to try to get over any difficulties. Okay, penultimate explanation. Dolby and Gull in 2001 bemoan the description of when events happened according to the traveling twin seems never to have been fully settled, and that one twin assigns 3 times to every event, and also that distant planets sweep backwards and forwards in time every time the twin moved. They say that GR is not needed for an understanding of the problem. They must never have read the 1918 Einstein paper. They refer to one twin as having hyper surfaces of simultaneity, sweep around or being overlapping. This is another of the frame jumping brigade, another of the outlandish things. Dolby and Gull have the usual complement of words, such as wrongly, common misconception, misrepresented when referring to previous papers on the paradox. And the last explanation which Kelly gives, now remember this book from Kelly is 2005. So the last one is 2001, which is Hawking. In a sequel to A Brief History of Time, again describes the matter as follows, and we quote, although it seems against common sense, a number of experiments have implied that the traveling twin would indeed be younger. Number of experiments. This is complete with lovely color diagrams, says Kelly, which give the statement a sense of importance. At least Hawking says that the experiments just imply and do not improve. I wonder if he is having heretical doubts. So he finishes up by saying, watch out for the next published explanation. Such papers comprise a minor industry. Will the author of the American Journal of Physics, which published over half of the above references, read this book and never again publish a paper on the paradox? That would be a coincidence. Okay, sorry, I've labored that a bit. And let me just see some comments coming in. Well, paradoxes really mean the theory is contradictory. And if people accept contradictions as a theory. No, we test. Okay, yeah, nothing new there. We already know that, James Keane. I really haven't been perusing the main comments, but Roger, I take it you still don't have sound. Does anybody in the Nick? Would you like to come in? Yeah, I was thinking of you, and you've signaled your hand simultaneously. So
first two comments. First two comments. So your litany of published papers shows that there's a tremendous amount of difference of opinion within the relativist community. In fact, I'm quite familiar with that entire literature, and I would say 90% of the so-called reconciliations of the twin paradox explicitly say that the twin paradox is irreconcilable, because the twin paradox is based on the explanation that it's special relativity's time dilation that's the cause. But almost all of the papers published trying to reconcile the twin paradox with special relativity say, no, it's not the time dilation, it's something else, it's acceleration. It's the observer's view of simultaneity, et cetera, et cetera. So, and it's amazing, despite at least a dozen different mutually exclusive explanations of the cause of the time dilation in mainstream journals, there aren't criticisms of those 12. Kelly criticizes them, but it's not one. If one writes a paper reconciling some special relativity problem, that's printed. But problems and flaws in that explanation are not printed in the major journals. So making that point, or those 2 points, I do have another video which does discuss the alleged reconciliation arguments of the twin paradox. And I think that's about 60 minutes long. I'll leave it up to you as to whether we go that way or have interactive.
16, 1-6. I thought you said 16.
1-6. Yeah, 1-6, I believe.
Okay. I personally, although we're running a bit out of time, I do think that would be worth looking at in view of my quickly going through all those explanations and your first video giving the explanation of this, or the introduction. So what do the other people in the green room think? I think we might show the video. Do you think that's all right, Roger and Jim? We go for the video. Okay. Roger says yes, but I can't bring you up, actually. Shall we go for the video, Jim? You're happy with that? I know we'd like to give him more time. So, okay, let's do that, Nick. Have you got it there?
I put it in the chat.
Okay, you put it in the chat. Let me go back to that. I'll do exactly what I did before. Don't see it now. Private chat.
Oh, maybe I haven't pressed publish.
Yeah. Okay, I have it now. Okay.
Yeah.
Okay. So just bear with me a moment, and I'll do my best.
By the way, that first video, I think, makes things very simple. And 90% of the references you cited just avoid the simple contradiction that I think Dingle brought up beautifully. And actually, there was someone at Harvard in the history of science, Hasok Chang, who analyzed objectively the literature about the twin paradox debate with Dingle and said none of his opponents addressed the questions he raised. Now, interesting, Chang then didn't come to the conclusion that there was a paradox. He just said that they didn't answer the questions that Dingle raised. So,
right,
they go off on tangents and really don't address that simple thing of the relativity principle plus special relativity itself would require that if time dilation is explaining real differences in proper time accumulation, that it leads to an obvious paradox, namely that clock A is slower than clock B and clock B is slower than clock A.
I mean, people like Langevin in the 1920s seem to appreciate that obvious fact, Nick.
Yeah.
But what he says, well, since special relativity is proven beyond reasonable doubt to be true by a panoply of experiments, we must find some way of getting over this apparent contradiction. That's the sort of logic.
Yeah.
That
The problem with the experiments is they were consistent with both special relativity and Lorentz's preferred frame view. So that was kind of a red herring there.
Yeah. Oh, okay. Well, I'll try that video now, if you bear with me just a moment. Yeah. I'll even remove myself for the moment, I think.
Hello, this is Nick of Time. Thank you for joining us for this 10th talk in the series. Let me know if you have any problems with the switch.
I've just stopped it momentarily just to make sure that it's working. You can hear and see it, can you? Nick, it was all right a moment ago, was it? Okay, fine, Jim. I'll go back then.
Switch to purple text. Someone had written in the comments that they were having trouble with the red colored text, so I've switched it. But if it causes others problems, we'll have to do something else. This first slide, we're going to review what we've been talking about recently, and then to wrap up and come to a conclusion on a main point, we'll jump forward to what we develop in terms of examining the empirical data. And then after that, we will go back to the talking about the twin paradox while it's fresh in your mind to make a couple of other related points to what we've been talking about. But I didn't want this main point to get lost. Okay, interpreting special relativities, time dilation, as describing physical effects, such as clock slowing, is invalidated by 3 levels of logic problems and contradictions. That's what we've just been talking about over the last several talks. Now, in addition, when we later look at the empirical data, we'll find that the GPS data is inconsistent with the interpretation of special relativity time dilation, causing clocks to slow down or accumulate proper time at a slower rate. I'll quickly make another point. So that leaves the other possible interpretation of time dilation. Namely, it's describing just observed effects. by just observed effects means something like when you have two twins and they walk apart, each will observe the other twin to shrink, but there's no actual physical shrink going on for either twin. So that's what just observed means. An observed effect, but there's no physical effect associated with what's observed. Now, there are no logic problems with that interpretation of the meaning of the special relativity's time dilation. But once again, we'll find out that the GPS data is inconsistent with that interpretation as well. So there's no viable interpretation of special relativity's time dilation that matches the empirical data. It matches some of the empirical data, but the total empirical data. All right, now we'll go back to talking about some other related aspects of the twin paradox. Okay, a lot of physicists agreed with our conclusion that you can't explain a net difference in clock readings, proper time readings, when you have two twins starting together and one makes a round trip. So a number of relativists, having rejected the original claim, have tried 20 or more different reconciliation arguments with different causes, like length contraction or relative simultaneity, etc., or combinations thereof. But when they do that, that's an implicit rejection of Einstein's twin paradox claim about special relativity's time dilation causing clock slowing. But note that none of these different reconciliation arguments, which are by and large mutually exclusive to one another and contradictory to one another, is no explicit or official rejection of any of them. So any argument that seems to reconcile a problem with special relativity is accepted, not criticized. Well, legitimate arguments and concerns and questions about special relativity, there seem to be censorship, particularly in the last several decades, publishing those in the top tier physics journals. Well, we'll look at, we can't look at all 20 of those arguments and examine them. That would just be too long, be a waste of time anyway. But most of them fall into one of two categories. So we'll look at those categories of arguments and dispatch a whole bunch of them by looking at the problems with that category. So in this talk, we'll focus on turnaround acceleration as cause of the difference in clock readings that Einstein alleged, or was implied by special relativity. Again, this whole category of argument concedes that Einstein's original claim that time dilation was the cause of the net proper time difference is invalid. In fact, Einstein himself in 1916 rejected his initial twin paradox claim and came up with a different argument, as did Max Born, and both of these were based on the turnaround acceleration. All right. The first problem with this whole category of arguments is if there's no clock rate difference during the constant velocity segments, then the so-called traveling twins clock must jump backward during the turnaround acceleration. In other words, let's say it's a very long round trip, 2 million years out and 2 million years back, and the slowing down factor is a half. That would mean the traveling twin, when he turned around, would have to lose 1 million years on his clock in, for example, just 2 days, if that's how long the turnaround acceleration took to go from V away from the stay-at-home twin to minus V, heading back towards the stay-at-home twin. Okay, let's look at other problems. Well, first, just to explain in the picture what that means, you have at the top of this picture the rocket going from event 1, which is the start, to event 2, which is the start of the turnaround, and that can be made arbitrarily long, like a couple million years. We're going from event 2 to event 3, from the start of the turnaround to the event, the end of the turnaround, that can be a couple of days. So that's very, very short. So here we have the rocket at event 1. It takes, let's say, 2 million years to travel that very long distance. And then during the turnaround, his clock will have to lose half of that time. He's going at 0.866 the speed of light. So that doesn't make much sense to have the clock jump backwards. Okay, the next general problem with this whole class of argument is that it requires 2 accelerations with the same parameters, the location where the acceleration takes place, the amount of acceleration going from V to minus V, or a total of 2V acceleration, and the duration of the acceleration. Having the same parameters for the location, acceleration, would have to cause effects that differ by orders of magnitude. You have the same physics for those 2 accelerations, but they're supposed to cause effects that differ by orders of magnitude. For example, we'll have 2 twin paradox scenarios where the relative velocity is V for both of them, and the duration and location of the turnaround acceleration is the same for both of them. But the constant velocity duration of the trip is 100 times longer. And that, according to special relativity, would mean that, or at least Einstein's claim, would mean that the effect would be 100 times greater. It doesn't make sense for something that has the same parameters to cause 100 times a greater physical effect. You can do equations where you come out with the numbers, and the numbers come out, but the implied physical model of what you're doing just doesn't make sense, and here's one way to express that fact. And finally, we have a third problem with this whole class, and this is the empirical data. The data from all particle accelerators show that clock slowing is a function of velocity. When you're accelerating, a function of instantaneous velocity. It is not a function of acceleration per se. Hence, trying to use acceleration as a cause for clock slowing has been shown to be invalid by the logic and by the data. Okay, that's another interesting exercise of showing how critical thinking can give a clearer picture of the validity and the problems with accepted arguments. And I'm just going to digress away from the physics to talk about critical thinking at the end of this talk here. I'm going to show 4 slides that were made by CNPS regarding their program on their campaign to restore critical thinking. And in this case, a subtopic to restore genius to human status. These were put together by David Hilster of the CNPS. This one says, "Dear Albert, I know if you were alive, you would look at the challenges and problems with your theory and even consider that perhaps you were wrong." And in fact, as we talked earlier, I think like on the first slide, it showed that Einstein did this. In 1905, he came up with his twin paradox claim about time dilation causing slowing of clocks, round trip. He got some criticism and problems raised by others. He thought about it, and he came to the conclusion that they were right. He did some critical thinking on his own part, and he came up with a different solution. So we're not here to criticize Albert Einstein. He did a lot of excellent thinking. Admire him, respect him, and he did critical thinking on his own. Let me continue. Yet many physicists today cannot let go of thinking of Einstein as infallible, like the Pope speaking ex cathedra or something. They often forget that you, Einstein, were in fact a human, not a god. Sometimes a picture like that picture on the right has a more memorable effect, stays in the mind longer, and this one says, "Einstein is in fact a human and not a god," by Professor Dr. Cynthia Whitney. Similar picture, great picture, I think David put this together, is Einstein and Jesus at the Last Supper, surrounded by the faces of a number of well-known physicists from different decades. It says, "The moment we stop worshiping, start thinking critically, and question others' truths is the moment science is free to move forward once again." Interesting thought, interesting picture. And here's David, he says, "Genius is an illusion. We need to start teaching critical thinking." Not about the stature of the person who's saying it, but the content of what's being said. And stop worshiping this illusion of genius, which keeps science from advancing. So thank you very much for joining us again, and we hope that you can join us next time.
Right. And obviously the recording of this session will be available as the others, but Nick also has his own YouTube channel, Nick of Time, I think it is, on where you'll be able to get, have a look at these videos again. Okay. let's see. I think a lot of the comments here are actually just about Roger's inability to get on. But let's just have a very quick look at the comments which have come in. There are too many of them maybe to go through now, because I haven't had an opportunity to when I was reading from the Kelly book. But there have been a lot of comments coming in. Let's see, are they positive or negative, or have we got people thinking about acceleration? Cornelis asked, do any discussions about twin paradox take into account the associated length contraction that must coexist with the time dilation? Well, I think there are similar paradoxes there. You know, the sort of the pole going into a garage of a finite length, and if the pole is longer than the garage, but it's going at a particular speed, it can fit in. You know, things like that. Yeah. Does anybody want to say anything about that? Nick, you in your analysis, do you bring in length contraction as well as a matter of consideration?
No, but others, I think Wikipedia may have at least one time tried to explain and reconcile the problem with the twin paradox by bringing in length contraction. But again, it's just, so it's been fully analyzed, and it has the same problems, but they're not as clear, because with the clock, you bring back the net proper time difference. But when you bring back a meter stick, you lose what happened in the interim of the round trip, because the meter stick, when you bring it back to a starting point, is going to be a meter stick. There's no cumulative evidence of length contraction. So bringing in length contraction doesn't help. I mean, it can, in some clever debaters, it can obscure the key arguments put forth in the first video, but it isn't a good reconciliation.
It didn't seem to have been brought in any of the explanations that I read from Kelly's book. But Andrew Kessler just says, in the example with a twin on Earth and one on the spaceship, they wouldn't have the same space-time interval, so I don't know why you would equivocate them. Well, that is the same argument as given in some of the explanations here. You know, just dismiss it because you say they're not in the same spatio-temporal system. Is that an explanation? One has to decide.
Yeah, let me just make a quick note to Andrew. I'm not saying Andrew is wrong or has wrong ideas, but I do get the sense that Andrew, in listening to those, is thinking of how can I rebut sentence by sentence. But even if you're 100% correct, often listening to critical arguments can greatly improve your understanding of something that's right, and at the very least improve your exposition of why you were right. So I'm not arguing with your position, but I'm just asking that you try and get the Gestalt picture first before creating rebuttal arguments. Because here, the point is nothing to do with what you just said. It's talking about proper time accumulation. That's a physical event. And we know that it exists. And from GPS data, we know that it's a function of absolute velocity with respect to a single frame. If you use, in GPS, if you use a inertial frame that's different than the GCI frame, especially one that's substantially different, moving at great velocity with respect to the GCI frame, you get the wrong answer and GPS would not work. And that is not consistent with special relativity. It's consistent with the Lorentzian preferred frame point of view. So what you say really is quite a red herring. And so many times people have brought up, I discussed that in terms of the acceleration of a red herring, and they're perfectly capable of understanding this if they would apply it and really think about what are the implications of that reconciliation argument. But they're in the mode of, hey, I got a rebuttal. Boom, that's it.
Yeah, well, that's
once they
basically
come up with something
Dingle
that, yeah,
observed. Dingle said it was a mindset, which you
Yes.
seem to be saying the same thing, Nick.
yeah.
Okay. We might have only time for one or two more questions, and I might bring some other people in from the green room. I think
Sure.
Cornelis wants to get in. If you give me a moment, Cornelis, I'll just finish to see are there any pressing questions, and I'll bring you in. Your camera's on now, anyway. And Roger, we'll try you in a second, Roger. Hoping your system is all right. So just give me a moment to complete these. Yeah, there are a few points here which we don't really have time to deal with. It might be appropriate to have another session on this, and indeed, Roger perhaps himself will, because Andrew has come back a bit with some other points there. So let me just see. Amritori says time is no physical existence and can't delete. What happens to clocks? Yeah, I mean, Amrit's point here, I think, is something that some of us might agree with. I think Nick would agree with it, and I probably would as well.
Thumbs up.
Yeah. Okay. It's not time itself.
Amrit is another person one should listen carefully to.
Yeah, and we have had him. We hope perhaps we'll have him back.
And I hope we'll have Vladimir on.
Yeah, Vladimir hasn't got back to me, but Stefan has. In fact, we're hoping to have him maybe next week perhaps. So, okay. Talking about irrationals. Let me just say, I think some of the private chat is just between you. Ian will not hear you, Roger, if you are backstage. Yeah. So actually, Cornelis, if you'd allow me, just bring Roger up, because he's meant to be the host of the show, and I don't know if he's back. So, Roger, can we hear you? No, it's still. There's still a problem with the sound. So we're going to have to decide offline, maybe by email or something. We can sort of, yeah. Thanks, Roger. Thanks very much. So Cornelis is next. You're up now, Cornelis. What's your observation?
Okay, I'm trying here on a cell phone, so I hope you can hear me okay.
It's fine. It's a little low. I don't know if you could turn up a teeny bit. It might help. But
maybe if I move closer to the microphone. Well,
yeah.
The other thing I was bringing up is about the length contraction. The thought there was that if there is relative velocity between the two, then there's also length contraction, so that the moving twin, would also experience a shortening of the distance, as well as a reduction, as well as a slowing of time. So effectively, they would cancel each other. You can't take one without the other. There is no, if there's a relative velocity, there's also going to always be a length contraction according to the theory. And so the two should work together, not just consider one or the other. So you have to change the distance that the twin is traveling as well. I don't know if that helps resolve it or not, but I don't see that. I've seen too many explanations where they account for both length contraction and time dilation simultaneously.
Well, remember that,
that was my
length contraction actually is space dilation, so it really compounds the problem.
Yeah, I thought they would basically work against each other.
Michelson-Morley experiment, where I suppose length contraction was first brought in to explain the same time occupied by the disparate paths. But then it was noticed that time dilation would as well. And I suppose the special theory of relativity was brought in to say both. Yeah, you have dilation in space and in time, applying the Lorentz transformations to be totally, complementary. In that one wasn't absolute; they were both relative. So,
because the way I understood it, the clock slowed down, but at the simultaneously when that happens, because the faster you're going, then your distance reduces as well. So they should counter each other so that you're traveling a shorter distance in
No,
a
the
slower
distance
time.
doesn't. The distance
No.
doesn't contract. The distance expands because, at least in terms of your observation, because your measuring rod shrinks, so you get a hell of a lot more meters for the entire
The measuring
distance.
rod, but the measuring rod is shrinking from the outside observer's standpoint, not from the inside observer's standpoint. It doesn't shrink
Well,
within
in terms
your
of the
frame.
twin paradox, if you were being consistent that the clock is slowing because time has expanded, the problem is that for length contraction, the reason why the measuring rod contracts is because space expands. So it's not a solution. It's a compounding the problem.
I think it deserved more thought, so I just thought I'd bring it up.
Yep.
Okay, thank you.
Okay, well, thanks very much, Cornelis. It's an interesting point, but I note that it hasn't been proffered as a possible explanation or a factor to consider in the standard explanations. I'm just looking again at one or two of the comments, Nick. And maybe people are saying you've said this before, and David Bauer. See, we may not have time to do this. This may be the subject of a further discussion, but he's asking you, Nick. Please explain how GPS data contradicts Einstein SR and how it is more consistent with Lorentz theory. Now, you've given talks on this. This could take a complete talk to do that.
Yeah, I think I have a talk in my repertoire, but I did mention it, and I think I can do it in a couple of sentences. The data shows, the GPS data shows, and that the cause of the satellite clock slowing relative to the clocks on the surface of the Earth is due to its greater absolute relative velocity. And of course, let's just stick to velocity and not gravitational potential. So the data shows that the clock slowing due to velocity is absolute velocity with respect to the GCI frame. So it's all the GPI data is only consistent with the preferred frame interpretation, where, at least to a very high degree of precision, it's the GCI frame. In contrast, special relativity says that you could get the correct answers if you use any other inertial frame as the base frame. And that turns out to be wildly incorrect, becoming more and more correct the more the inertial frame that you choose differs from the GCI frame. And this is my colleague, Ron Hatch, the late, great Ron Hatch, who had 30 plus patents in GPS and was known to have the most detailed knowledge of not only the GPS data, but was also knowledgeable about the NASA data and the data from the VBLI telescopes. He said exactly the same thing. And it said it disproves special relativity. He was quite clear about that.
You know, there's some further comments coming in from people like Kev and Andrew and so on. And asking a bit more about this. I think, I don't know if it was Kev, but I'm only scanning the comments very quickly. I think he referred us all to the Feynman lectures on physics, and maybe some people suggest that everything has been explained quite adequately, but others would doubt that. Now, I note there's one other gentleman in the green room. It's James Keane, who hasn't spoken. Would you like to say a word, Jim? We always value your response, good, bad, or indifferent, or.
Well, I'm just enjoying the show, and I'd like to thank both Ian and Nick for their contributions today. It's been quite an interesting story. Thank you.
Well, thank you very much, as always. And okay, so we'll at least we must have done something right. I mean, this was a bit of a Heath Robinson affair, as we say, but okay. So unfortunately, Roger's sound is the problem. His video seemed all right, and Jim has been actually trying to help him, work with him in using programs, but I think we might have to do that offline. If I can help, fine, and perhaps with the CNPS, because I might say that Roger may very well want to give what he had originally intended to give today, notwithstanding our detailed consideration of the same subject, because there's a lot more to say in the subject. And I think this was one of perhaps 7 presentations that Roger had proposed at the end of last year in regard to what he would consider contradictions and, people not sticking to their arguments and moving goalposts and all that, in particular with regard to aspect of special relativity. So I think he may very well not only want to come back to the subject the next time, but then give maybe another 5. I think he's spoken about twice on the subject. Give another 5 talks on these seeming contradictions. But he's going to have to sort out this problem first. And unfortunately, I'm still not in the position to be able to guarantee that I can attend more than every fortnight. However, next week will be one of my shows, so we are hoping to come back and have an invited presentation then. I was glad to hear Jim's words there, because I hope you'll all forgive us for the technical difficulties which can arise, and Roger's impossibility of getting in, really, so that just by chance I had looked up Kelly's book and said, oh, maybe if they give me a minute or two to talk, I might just tell them there are 52 proffered explanations. I didn't think that I'd have the opportunity of going through them all, albeit fairly quickly. And Nick's 2 videos, I had actually heard them before and seen them before, but it's always refreshing to have sort of a revision of them, and certainly in line with our thinking today on this particular subject, it was very beneficial to have that. Sorry, you're mute, Nick. Your lips are moving, but you're mute.
I think I have about 5 or 6 videos on the topic of the twin paradox, and I put into the chat, I think, the URL of my YouTube channel. I put it in there.
Yeah. Sorry.
There it is. There it is. Okay. Hopefully that will work.
Yeah, David is coming back, but unfortunately he's not in the green room, so it's difficult to, converse back and forwards. I'm not sure if we've actually fixed a date. I think he wanted to postpone it a bit, so we'd like to know the date that he's speaking on GPS. But he would like to know before that the answer to the questions I asked. Now, David has answered. Maybe if I go through I don't know how many there are, 144 comments. I've picked out one of David's, but
yeah, David, feel free to email me any questions you want.
Yeah, please do that. Please email Nick, and if you think I can be of help, email me as well. And maybe let me know when you want to give this talk, and we can just pop you in. We're free basically from the second week of March, I think. But before that, we actually have bespoke talks. So we look forward to that, David.
And by the way, to James Keane, I watched
yes.
his binary mechanics talk, and I thought it was excellent. Excellent.
Okay. And I thought you had it's sort of a way of looking at everybody, but you don't. So just as soon as you said that, Jim raised his hand. So I'm going to bring him up now, Nick. Yes, the floor is yours, Jim.
Well, thanks, Nick. A question has occurred to me after so many sessions about SRT. It's a real simple question. Maybe we should have a session on, is special relativity theory good for anything? I mean, is there any redeeming value? Is there anything in special relativity theory that is worthwhile in any way whatsoever?
Well, it did bring out Lorentz Lorentz. I don't know if invariance is the right word, or covariance. Lorentz invariance, because there are certain things that are invariant with respect to any inertial frame. Like, interestingly enough, despite the physics explanation being totally different for clocks accumulating proper time differently, the total net prime total net proper time difference in a twin paradox scenario can be calculated correctly by any inertial frame. And that's because of Lorentz invariance.
Well, but that's work of Lorentz, is
yeah, but
by special.
Yeah, but we might not have seen
theory,
that it was the same from any.
Doesn't have anything in it that is aside from other people's work, like Lorentz. Is there anything that Einstein actually added that's of any merit whatsoever?
Well, that is a very interesting
you have to ask
itself.
This question after so many sessions.
Yeah, and
excuse me,
it's a subject which could well be valuable to look at whether Einstein added anything or whether it was basically just as was said in the very early days, a theory of Lorentz and maybe Poincaré, and he might have added, whether he added anything. That's one interesting point. Whether he plagiarized it,
and
whether
Ian, if he did add anything, is there any merit to it whatsoever?
Yeah,
because I'm hearing so many critiques from Nick and other great minds here on CNPS that like I'm sort of inverting the game now. I'm saying, is there anything that Einstein contributed which has any scientific merit whatsoever?
And that's a very valid question. So that's the other way of looking at it. And I think David,
I ask, that's David my challenge. If anything has anything positive to say about Einstein, contribution to science, I'd like to hear what his contribution in fact was.
Just like I said too.
David de Hilster has praised Einstein in some ways, but he is a great man for saying that relativity isn't used practically. We don't use it in sending men to the moon. We don't use it. And so that's the other way of looking at it.
But as I said to Andrew Castro, any criticism or different perspective can often help, even if it's wrong. So we have, I think, better insights into Lorentz, the meaning of Lorentz theory, from having gone through this, unfortunately, century-long debate of what it's not, for instance, and how to be sure you're explaining it correctly and making the proper context for it.
Well, it'd be interesting if there's anybody out there that can give us a presentation on what Einstein actually added to science. I'd like to know, because it seems like there's nothing there except other people's work.
The core gravitational equations for general relativity are non-relativistic, so I have not heard real
any work, purported independent work on the photoelectric effect or Brownian motion. Whether it was indeed an addition or fundamental. We could discuss that, and it would be something which I think would be fundamental to the ideas or the existence of the CNPS, I would say, because if you go into the general website, you will see things about why Einstein became famous, written by de Hilster and so on. And we're looking at maybe political things rather than scientific. So that would be an interesting question in itself.
Yeah, I mean, it would be interesting, because if someone could come forth with, here is a brief list of what Einstein actually contributed more than just citing other people's work, like Lorentz, that would be interesting. And well, that's my thought for the day. Thank you, Nick.
Okay, well, thank you very much for that, and I'll give it some thought. And if we have any other volunteers, including your good self, Jim.
Well, no, I mean, I can't find anything yet. So that we have to maybe keep looking. Maybe Einstein actually did make a contribution to science. Who knows? But you never know it by listening to people here. But maybe he did.
Well, Brownian motion is a totally different thing than relativity. So,
yeah, okay, and maybe that was fundamental, or maybe again he was just building on what the botanist, Scottish botanist Brown did many, the century before that, and worked further. But I think perhaps our discussions here have been rather an antidote, maybe an extreme antidote to the prevailing view. One of the things I'll confess to you before leaving now, because we're running out of time, is that one of the things, whenever I see something that should not be questioned, rubbish, and people are impatient, my ears prick up and I say, there must be something dodgy about this. And that's one of the things that got me to question this whole thing, that you couldn't publish papers on it and careers were dependent upon it and so on. But
yes, indeed.
Yeah, but so we might have gone to the other extent to a certain extent. For example, there's one man here who hasn't directly asked questions, but he came on a couple of weeks ago, and also last week, I think, as well. But I don't think he just started with his first thing. He said something like "Down with Big Brother Einstein." It was like almost a fanatical thing, and that would be very unfortunate if we just start taking up. Sorry to interrupt, but Kev said he'd be willing to take up that challenge. So
great.
So I just respond. Kev, let me know details. I'll give my email address. So just so we capture that. There's going to be said that. I mean, for my own part, I may appear to be claiming to be overly moral, but I want to hear all sides, and I'd be very happy to hear Kev or Andrew give us a talk as to why we've been all very much mistaken in criticizing Einstein. His theory, Stefan, for example, who'll be speaking to us very shortly, says Einstein's theory explained Thomas precession, transverse Doppler, relativistic beaming, and other phenomena. And I think he'll be dealing with that actually next time. But the question is whether it's uniquely dealing with that, because as I've pointed out many times before, something can explain or appear to encapsulate observed phenomena, but that doesn't prove it to be true. But if it contradicts an observed phenomenon, well, then that disproves it. So you can disprove something. I would claim that there are certain fundamental experiments in nature which do contradict the orthodox tenets of special relativity. I would say that. Okay, there are a lot of questions coming in, and I hope Kev gets back to me, and I hope David comes back to me as well with more specifics on that, and we can look forward to that. I think, by the way, I normally don't give a preview because I like it to be a bit of a surprise, but I think Stefan will be looking at the Solari transforms, which I think he's adverted to, and he might be suggesting how they're superior to the Lorentz transforms. I myself think that these are just like fixes of a problem, which has been looked at in the wrong way. But anyway, we'll talk about that. Okay, everybody's interested in that. All good things. You've all been very patient with us, and I hope we resolve this matter with Roger, and maybe we'll have to bring Franklin in to assist as well. So we ought to meet up later in a forum if anyone wants. Yeah. Well, if you wanted to organize that question through Zoom or something like that, that would be quite advantageous. And once I stop the recording, which I must now, the people in the green room will be able to have a chat for a few minutes if they wish. That's possible. So I'm going to close the stream now. It's a shorter meeting because we were about 20 minutes late starting in the first place. Yeah, well, thank you for the good words, question. And thank you, everybody. Thanks for everybody else. Yes. Thank you all for participating. I must remove Jim just for the moment. I consider this a bit of a step in by both Nick and myself in having some material to deal with a germane subject. But Roger is free to come back and talk about it again if he wishes next time. So I'm going to end the. I'll just bring Nick down now. Thank you very much for helping us out. Well, it's Roger's show, and I hope we didn't steal the limelight. But what could we do? We look forward to his coming back next time. And keep an eye on the notices. Do come back, all of you, into the media, and do feel free. We do have spaces free in the green room. We can only take 10 people, but we sort of typically have 5, and we might have a presentation 6. So we could certainly fit 2 or 3 more people. That's no problem. So I'm going to end the stream. I'm going to thank you all sincerely for participating, for your patience in my going through the sort of very turgid prose of all those 54 contributors. And thank you, Nick, very much for those 2 videos, bringing them on stream just like that. So I wish you all a very good day wherever you are in the world. You're probably mostly in North America, but I think not all. So good day, and thank you again for being our guests.